Good afternoon. Thanks for sticking around. I think this is the last session, right? So it's been a long 2 days, I'm sure. I want to talk a little bit about working with system designers to improve security, and more specifically on application security. My name's Chris Ng. I work for a company called Veracode, and we do application security testing as a service. I spent my entire career in AppSec, so starting from about 15 years ago, focusing more on offense, breaking into applications, helping companies figure out how to fix their software by virtue of breaking into it. Did that for about 6 or 7 years, and then joined Veracode to start focusing on defense instead of offense and trying to solve the problem at a broader scale than one app at a time, sort of piecemeal ad hoc. We figured there's got to be a better way to do this. And so I've spent since 2006 working with Veracode on more automated solutions for improving security across the board with applications. And I don't really want to say too much about this other than what you learn as you go through from offense to defense is that defense is a lot harder. Defense is insanely difficult because you have to block everything. The attacker only has to find one way in. The defender has to block everything. So this is something that obviously is constantly on our minds. Everybody who's dealing with any sort of software that has access to sensitive information is constantly thinking about breaches and the implications of getting hacked. Security teams and development teams and infrastructure teams have an interesting relationship. Especially as of late, you have application development moving towards a model that is more rapid. Agile Scrum, you probably hear a lot of. We use Agile at Veracode. And when you shift the application development approach from a traditional waterfall style approach to something that's more agile, oftentimes the security teams are the ones that get left in the dust. You may think that the dev teams are still operating in waterfall because as a security team, you're still testing every release. You're testing right before it goes out the door without even realizing that the entire development structure has changed underneath you. And this happens all the time, especially with the complexity and the different ways in which development teams interact with one another. And so the poor security guy kind of falls behind. And that's not good for anybody. What I want to do is go through 5 lessons, techniques, approaches that I think are important for a security team to start addressing this problem. So that'll be your takeaway. We'll go through each of these. There's specific actions that you can take in each case to make improvements. So the first one, you've probably heard this before, test early, test often. If you ask development teams to produce secure software without a systematic testing, it's almost like asking them to drive the speed limit without giving them a speedometer. Developers need regular feedback about the quality of the software they're developing, and without that constant feedback, they have no idea how well they're doing against whatever measuring stick you're putting out there for them. Security weaknesses will hide until later in the project when they're more costly to repair. When 6 months after the code's been written, you find some vulnerability that you then have to go back and try and figure out, okay, who wrote this code? Is that person even still here? Do they work for the company anymore? Have they moved to a different team? If they do still work for the team, do they even remember that part of the code? Because if you're a developer and you think about what you're working on week after week, you're moving on from one functionality to the next. You may not remember what you wrote. And so the more that you increase this latency between writing the code and testing the code, the more difficult it's going to be for the developers and, of course, for the security team. You may have heard the notion of that you can't scan yourself secure. right? You can scan all you want, but unless you're doing something about it, it's not really helping. So it's not enough to just push testing back into the lifecycle and start testing every night and giving yourself a pat on the back because you're doing all this great testing. Scanning is only one part of the issue. There's a lot of process and workflow that goes around testing early and often. And you have to evolve beyond this, the old scan and scold that security teams are so fond of doing. Right? We go in and we do a pen test, or we run an automated scanner, and then we go to the development team and say, here are the 500 reasons why your baby is ugly. And that's just not good. That's not beneficial for the working relationship between those teams. With our product, actually, we scan for good as well as bad. So for example, you're looking for SQL injection vulnerabilities or cross-site scripting as bad patterns, anti-patterns that produce exploitable issues in software. But we can find the cases where they do it wrong, but we can also find the cases where they actually did it right and give them that feedback as well. So you can say, there were 500 cases where you could have created a SQL injection mistake, and you did it right 450 out of the 500 times. Doesn't that sound different than, hey, you have 50 vulnerabilities? It's reframing how you do that. And so you're scanning a lot. You're not just giving them the negative, you're giving them the positive, and you're doing it at regular intervals. And that sort of continuous feedback between the teams is what's going to lead to higher rates of remediation and more cooperation between the teams. The way that we deliver our service is cloud-based. And so we have the unique perspective of being able to look at all of the software that gets scanned through our entire service and report on the trends that we're seeing, not only in the percentages of flaws and the likelihood and prevalence of flaws in different applications, but also how good are different companies, teams, languages at resolving the issues that we find. And again, like I said, it comes all back to remediation. So every year, we take a 18-month slice of all of our data. We anonymize it, and then we slice it by language, by industry, by application type and size. And we try and pull out some nuggets of information that kind of gives us a view on what's going on in the security of software. And so this shows you the percentage of improvement between the first scan and the second scan of the same application. So you scan it, you find some issues, you fix some stuff, and then you go back and scan it again to see if those things are remediated. And as you can see, people don't fix everything the first time around. That's pretty reasonable. There may be a lot of stuff to fix. It takes time, it takes budget, you have to prioritize. But this is what we are seeing. It's interesting that in PHP, 50% of the SQL injection gets fixed between build 1 and build 2. Now we have to kind of guess about what this is telling us. Maybe it's easier to fix SQL injection in PHP. Maybe our guidance is better in PHP. Why doesn't anybody fix directory traversal the first time around? That can be a pretty big, significant issue. If you can access anything in the file system by virtue of manipulating a request, that's a pretty big deal. Why aren't people fixing that? If we take a different look at the data, when we scan an application, we start it on a 0 to 100 point scale, and it's kind of simplistic, but it encapsulates the security quality of the application in a really easy to understand number. So 100 being the best, and subtracting from 100 with the different types and severities and number of flaws. And so this is a whisker plot showing the security quality score of the applications that we've scanned in our system, build over build. And again, this shows that developers don't do a scan, fix everything, and wipe their hands of it. They gradually fix things over time. And as you're fixing things over time, also, you have to remember that you're introducing new functionality along the way. So what you may see is a gradual improvement, and then kind of around, in this case, build 5, build 6, it kind of slumps a little bit and then starts going back up. And that's natural. That's what you expect, unless the application is purely in a remediation mode. But most projects are constantly being added to. So you're fixing problems, you're introducing new problems, You hope that the rate at which you introduce new problems is slower than the rate that you're fixing them. And that seems to be the case here. And this is averages. This is over about 20,000 applications. And you can see there's a wide range there. The median is in the notch in the plot there. And then the top and bottom of the box show the 75th and 25th percentile. So there's a range, but you can see generally it's getting better. And this is because of the fact that they're doing it early, they're doing it often. You don't get to 9 scans of an application unless you're pushing it further and further back into the dev cycle. And so this shows that what you really need to measure is the remediation rates. You have to focus on that, not so much just, like I said, the scan and scold, the counting vulnerabilities. Counting vulnerabilities doesn't do anybody any good. Every app's going to start at a different point. What you care about is this getting better. Number 2, test in production. Security is constantly evolving. Attacks are constantly evolving. And just because we scan something as we're developing it, and we get it to a pretty good state, we're happy with the score, we're happy with what we've remediated, and then we put it out there in production, that doesn't mean it's safe from now on. The code may not be changing, but the attack landscape is changing. The tools are getting more evolved. The attackers are getting smarter. And so this is something that you have to think about, that it doesn't just end once you deploy. You have to think about what's going on after that point, and is it still safe with the changing landscape? If you take a sort of diagram of an opportunistic attack, and sorry if the words are kind of small here, but the pictures are the important part. Real attackers are going after your production infrastructure all the time. Anybody know how to get a free penetration test? Put something on the internet. You're getting a free penetration test every day. You're just not getting the report. Opportunistic attackers are focused on getting information, whether it's credit card numbers, whether it's passwords, PII, what have you. And they're attacking it from an economic standpoint. Get it for as cheap as possible. Why expend the effort attacking something that's fortified and locked down really well if you can find another way in? The notion of the weakest link. You're always going to go after the weakest link. And so that's what the opportunistic attacker is going to do as well. If you've got 1,000 websites out there, is he going to start with the premier flagship application that's probably had more security testing than anything else? Or is he going to find something that you forgot about, that's maybe out of date, that's using old technology, you haven't patched the server, and once you deployed it 3 years ago, you haven't looked at it since? They don't care. You look at this, the strong application, you look at the weak application, you're going to find a way in through the weak application, because ultimately on the back end, a lot of those databases are connected, or they're sharing the same machines, or they're on adjacent segments or whatnot. So the attacker is always going to be going after that weakest link and go from there. So the question to you is, knowing that that's going on, knowing that people are probing your perimeter all the time, do you have any visibility into what they're going to find? Do you know what your perimeter looks like from an application standpoint? You can't protect it if you don't know about it. We developed a service at Veracode that does this sort of thing, and it came up not because we thought, hey, we should go do this discovery thing and figure out how to search the perimeter. We had a question from a customer that said, oh my God, I have to get rid of all the, they had a mandate to get rid of all the SQL injection. There was some pressure for it. And they said, we don't even know what we have. We don't even know how to find all the applications that we have so that we can then try to figure out if they have SQL injection, so that we can then figure out how to go and fix it. So that's a tough problem if you're starting with that little knowledge about what you have. What we ended up working with them on was an approach to getting some visibility into what they had. And we started by asking them for a list of all the IP addresses that they knew that they owned. That's actually pretty easy to get. Not always in one place, but your infrastructure folks know what IPs you have. They also know all of the domain names that you've registered and that you own. So that's a good starting point as well. And so we took those two pieces of information and said, what can we find out from this? Just this information in a very lightweight, non-intrusive way, because we don't have the permission to attack every site we find. All we want to do is find out if there's a website out there that may be running an application that you own, and then compare that against the list that you think that you own, if you even have that list. So we start by taking these domains and IP ranges. We run a few things on them. We do some DNS lookups. We do some zone transfers. We check for wildcards. All things that are actually probing the DNS system, not the machines themselves. Then we do some very focused port scanning on all the IPs that we discover as a result of those first 3 steps. And we look for web servers listening on common ports. And there's about 20 different ports that most web servers tend to listen on. 8443 obviously, but then 8000, 8080, and there's some others that statistically show up more often. Then we do a very light crawling of the pages that we find. So if you fetch down the front page of CNN.com, for example, you'll find references in that HTML page to other servers at CNN.com. And so if we see, chrising.cnn.com, we'll write that down as, oh, here's a domain that we've discovered. And it's part of CNN.com, so it probably is a valid host, and it probably belongs to this company. And so you repeat that for everything you have, and you iteratively increase the list of domains and IP addresses and hosts that you believe to be owned by the entity that you're looking into. Then you start doing a little brute forcing. Let's say you find web.veracode.com. Well, maybe you should look for web 1, web 2, web 3, web 4, web 5, because that's a common sort of thing. Maybe you should look for stage.veracode.com or backup.veracode.com, because those are common names that once you find a domain, people tend to use the same host names, mail.veracode.com. Right? So I may not have come across that in any of my other process, but I can guess once I know domains, some host that might be there. So anyway, we go through this whole process, and in the first case where we did this, we ended up finding something like 300 or 400 web applications that they didn't know about. This is a global, huge company, so don't let the numbers scare you off. But every time we do this, we find websites that they didn't know about. Sometimes they're old marketing sites that were set up for promotion, like a microsite, and they were meant to stay up for 3 months and then be taken down, and they were never taken down. And the back-end database has all sorts of registration information for people that have put in their information. Sometimes people just forget about sites over time, or don't realize that, oh, we had hosted this one in this facility instead of on our own infrastructure, and you just forget about it. So we found a lot of these hosts, a lot of these websites that the company didn't know about. And it's interesting, you think that, okay, well, now that we know them, we're going to scan them all. But actually, that didn't turn out to be the case. They decommissioned about 1/3 of them, just because they knew that they were there, and they looked into it and found that they weren't using it anymore. Why try to secure it if you don't need it anymore? Just get rid of it. Reduce the attack surface completely. And then for the ones that were still there, that were needed, then we went and did sort of an unauthenticated, broad, parallel scan of all the websites, just looking for SQL injection, because that's what they were interested in remediating. Yeah, they may have had some other issues too, but they had a mandate to get rid of this. So we in a very focused way, ran, God, I don't even know, can't remember now, like I think 3,000 websites, purely unauthenticated, purely looking for SQL injection in about a week. And we can do it faster than that now. This is the scale that you have to start thinking on when you're defending an enterprise. Locking down and securing that one app, or those 5 critical apps, or those top 20 even critical apps, which has been the historical approach for a lot of big companies. Here's my most important stuff. Let's lock this stuff down, and we'll get to the other stuff later. You have to take this holistic approach, and that means looking at the perimeter and seeing what's out there and figuring out what the weakest link is going to be. Educate everyone. And this is not maybe what it seems. What you think I'm going to say, or what I think you think I'm going to say is, go educate those developers, teach them about security. They need to shape up and learn about security. While that's true, in most cases, you actually need to involve everyone. You need to educate everyone in the process, every stakeholder, about what you're doing and why you're doing it. The managers need to understand the rationale for it. Individual developers, sure. The QA engineers should understand what you're doing and why you're doing it. The product owners, the systems engineers, the people standing up the hardware that's going to support those applications, they need to understand what you're doing and why you're doing it, because that's going to help with alignment. Everyone needs to have a basic understanding of application security fundamentals so that you can speak the same language, so that when you say cross-site scripting, people know inherently what the impact of that is. They may not need to know the technical details of how to fix it, but they kind of need to know if they should panic when they get a SQL injection versus a info leak. Basic security education. And building those bridges across the different groups is going to make it more likely that the security team gets involved and gets asked for their opinion on key decisions. So they keep you in the loop when you keep them in the loop. At our company, we have really one big product that's composed of a bunch of little products, but it's all served up through the same web platform. And we have about 8 different Agile Scrum teams working on different components of that, on different schedules, with different iteration lengths, all feeding into the same product. My team's responsibility, one of our responsibilities is product security, so making sure that our own stuff is secure. So we actually have to work with each of these individual teams, be aware of what they're producing and when, what their deadlines are, what their motivations are, what their constraints are, how they're measured, and work with them to incorporate security testing, not just automation, but also some manual code reviews, some consultation. What should I be worried about when I'm developing this file upload feature, for example? So the education process goes both ways. Stepping into this, if you just stepped into this enterprise that had 8 Scrum teams on this product, and somebody said, go secure the process, and you try to do it blind without understanding how those teams operate, how they work with one another, how they fed in, what the structure was, you would fail immediately. We have had to work very hard to try and understand exactly what's driving each of these different teams. And the team working on our dynamic product line has very different motivations and very different work style even than the team working on our web platform. They're all following Agile Scrum. There's a series of rituals and rules and structure that are followed when you do Agile Scrum, but within that, each team has the leeway to shape it however they want to do it. And so we have to understand the kind of the personality of each team to do that. And so the education goes both ways. We have to teach them about security, make sure everyone knows what we're doing, why we're doing it. But then we need to learn from them how they build software and what's driving them. Nobody wants to build bad software. That's the first thing to get into your head, is like nobody is trying to create software with vulnerabilities. Vulnerabilities get there because of budget and because of lack of education and because of ship dates. So this is something that is a constant evolution. Agile Scrum itself is focused on continuous improvement. You're supposed to, at the end of every iteration, you go back with the team and you talk about what went well, what didn't go well, and what should be changed for the next iteration around. So the next 2-week or 3-week cycle. Same thing for this. We always are thinking about what's going right and wrong with the security process and trying to improve it as we go and trying to get more aligned with the teams and work within those teams. We even sent somebody from the security team to Agile Scrum training, so to become a certified Scrum Master. That's not something you would normally have a security person do, but it paid huge dividends because suddenly he's speaking the same language. They're on the same page. That was one of the best things that we've ever done. As you're going along and you get more mature, you can start teaching the engineers to fish themselves. Instead of saying, you made this mistake here, say, why don't you watch over my shoulder as I do this little pen test, and you can learn some of the techniques. Or you start to give them checklists for, okay, if you're doing an authorization check in this app, here are the things you should keep in mind, and by the way, because I'm familiar with your code base and the way your team works, I know that these are the 3 interceptors that you should be picking from in your code. Like very prescriptive guidance. So that's all in education. Set measurable goals. The goal should not be your software is secure or 100% secure. Because what does that mean? A pen test is a point-in-time check. A scan is a point-in-time analysis. It could be secure today, and it might not be secure tomorrow. So it's unfair to ask a dev team to produce a high-quality product without giving them clear criteria against which to measure. Policy alone isn't sufficient. Policy is part of it. But you have to be thinking about capturing things as acceptance criteria within a feature story. So when you're creating this new feature, it needs to work in this way, it needs to do these things, and it also needs to validate input, and because it touches the database, it needs to use parameterized queries. That's a goal that a developer can meet because it's very specific. The end result is you may not have those SQL injection vulnerabilities. But if you just said, don't write code with vulnerabilities in it as the acceptance criteria, what are you measuring against? If you can't be specific in your project requirements and your security requirements, you should expect to be ignored because it's just too vague. When we do look at it from a policy perspective, what we find is that just because you're developing in an agile workflow, you're developing quickly and releasing often, it doesn't mean that security has to go out the window. In this chart, we measured different types of software. So you can, whether it was internally developed or whether it was purchased or open source, you can kind of ignore that and just look at the overall at the bottom there. But this shows, given the policies that enterprises were asking their dev teams to adhere to, and that policy could be anything from nothing in the OWASP top 10 or no cross-site scripting. It can be whatever they want it to be, a series of rules and grace periods and whatnot. And this shows that for applications that initially failed that policy check, when they went back and addressed some of the issues that needed to be fixed to meet the policy, 82% of those were able to do so within a week. And then you can see how the rest kind of plays out into the 2 to 3 week, 3 to 4 week, 4+ week time frame. Now part of this is that the policies that are being set may not be extremely rigorous. That's fine. You can start with something that's not super rigorous and increase it over time. What we found is that you can't just be draconian and scare people off and say you can't have any vulnerabilities. That's our policy. It has to be reasonable. So in addition to being measurable, it has to be reasonable. This is a different view of data from third-party programs. So this is specifically applications that are written by an outside party. So imagine a commercial piece of software that you're buying and then deploying in your environment, or you're buying it and you're integrating the library into your own code. And you know, the point to get across here is some of our customers that do the third-party testing have a very programmatic approach. They set clear, reasonable, measurable guidelines. It's built in their contract language. They have good time frames. They have escalation procedures. They have penalties. Those are programmatic ones. The other group of customers, they do it more ad hoc. They say, oh, well, we're going to start using this product. Well, we think it should be this secure, and they come up with something on the spot. Or they think about it for a little bit and then hand back a set of requirements to that company. And then for the next company, the next piece of software they buy, they may have different requirements, different penalties. And to me, that falls under less reasonable because you can't predict it. It's not consistent from one vendor to the next. And we find that when you do go in with that programmatic approach, you're setting reasonable, clear, measurable guidelines. You get a higher degree of participation from those software vendors If you're dealing with internal apps, you could just replace software vendors with dev teams. You have a higher compliance rate. People fix stuff quicker. They don't leave it out of compliance for as long. So measurable, reasonable guidance is pretty key. And the last one is kind of ties into that a little bit, which is to remember where your software is coming from. Nobody writes a piece of software entirely from scratch anymore. If you're building a web app to put out there to sell something, you're writing some custom code, sure, but you're using a lot of libraries. You're probably building on top of some web server, application server that was already out there. You buy some commercial product to do the spell checking component, or the XML export component, or the PDF creation. Right? All these little pieces, you stitch them together and you create one cohesive application, but you haven't written all that code. And historically, up until very recently, when you've been hearing the word supply chain a lot, companies would focus very much on testing only the code that they wrote. And if they felt that they had good coverage of that, then that was enough. And what it was doing is completely ignoring the fact that a lot of that software that you're integrating into your own product has vulnerabilities. You didn't write it, but ultimately it's your name on the website, it's your domain, it's your data being protected by that application. So if it's vendor X's fault that your website gets hacked, it doesn't matter, it's still your website gets hacked. You're the one in the news, not them. So supply chain is something that should be top of mind as you're developing software and as you're thinking about securing software. Just gives you a few ideas as to, areas to think about. Are you doing the same thing for your offshore development as you do for your internally developed stuff? What sort of vetting process does that code go through? Commercial software, we already talked about, stuff that you're buying that's either a packaged product or a library or something that gets integrated. Mobile stuff, a really common trend is to have your mobile applications, for your own company developed outside the company, because not every company has that talent pool of mobile development. And so it's very easy to go out to a smaller shop who is very nimble and they know this stuff and they keep up to date with all the dev frameworks and iOS 6, iOS 7, changes like every 6 months. It's easier to go out and say, hey, I want you to write my banking app for me, which is great from a talent and availability standpoint. But then some people forget to security test that because it wasn't developed in-house. Another thing to think about, to what extent are you using open source? And to what extent are you taking open source and then customizing it, maybe introducing more vulnerabilities in the process, and then just assuming that it's secure. That model, the whole philosophy that open source is always going to be more secure because there are all these eyes looking at it, and therefore nothing will slip through. I think that's been proven time and time again to be false, because unless somebody's being paid to look at the security of it, it's still just sitting there. The code's still there. No one has to look at it. Yes, it's available to look at, but it still takes time. It still takes effort. It still takes money. So I wanted just to focus in on one little aspect of the supply chain. We've already talked about commercial software and libraries, so I wanted to show you a little bit of data that we have around mobile, which is, to me, pretty interesting. We took a look at the top. So Google Play Store on Android is broken up into categories. So when you go to download an application from there, an app from the Google Play Store, it's like games or wallpaper or education. So there are 27 categories. So we took the top 100 apps in each of those 27 categories as of the end of 2012. And we ran them through a different type of analysis we do, which involves some static analysis. It involves some dynamic instrumented analysis where we actually just run it in a sandbox and exercise all the functionality in an automated way, and then watch what the app does. When does it generate traffic? What sort of APIs does it call? That sort of thing. And when we did this for those top 2,700 applications, it was very interesting. The types of APIs that those applications called was surprising. 91% of them used at least one API call that was asking about your identity. And you can see what the others are. 2/3 of them queried your location. Now, a lot of apps do need your location. Google Maps is not going to be very useful if it doesn't query your location. But really, do we think that 2,000 out of 2,700 apps, my math is probably wrong there, but do we think that that many apps need your location data? Probably not. So a lot of these apps, it seems, are over-requesting. They're asking for more information than they need. And from an enterprise perspective, and particularly from a BYOD perspective, where you're allowing apps into your enterprise and letting people run them, anything that accesses data on the device, where the device may have commingled personal and enterprise or business data, information leakage is a pretty big concern. And so this kind of ties in with that, looking at what these apps are actually doing when you're running them. File system, 90%. Remember how I said we instrument the applications, we run them to see what they're doing, and we essentially, in an automated way, click through the UI and exercise as much of the functionality as we can? Well, because it's sandboxed, you can actually watch all the data coming in, going out and coming in to the application by IP address. And you can see where the data is going just by looking at the addresses in the packet. And then you can take the IP address and you can reverse lookup using a GeoIP database, which are publicly available, to figure out if I have an IP, what is that associated with geographically? Is the IP address associated with Australia or China or Japan? And so this is the map that we got when we took those same 2,700 applications, instrumented them, watched the activity that they were generating, and did a reverse lookup on the GeoIP. So you see a lot of data being sent to US locations, which is probably not surprising. A lot of data centers in the US. A lot in Europe. You got some stuff in China and Japan over here. Russia, Brazil. I don't know what is there. Something in the Caribbean, yeah, but I don't know what country is. Country is probably about 1/10 of the size of that dot. But it gives you a very interesting macro view of, okay, where is all the data going? If I had one person in my large enterprise that had each of these apps installed, this could be a relatively accurate representation of where people are sending data to. Now, we don't know what type of data it is. This is not to say that all of it is malicious. They may just be calling back to fetch an image. Or they may be sending your location data to an ad network that happens to be located in the Philippines. That requires more introspection, more analysis to figure that out. But this gives you a good macro view. Anybody know what's in the middle, right there in the middle of Russia, where there are no cities? Nope, Moscow's somewhere over there. Or what's in the middle of the Australian desert or the middle of the Brazilian rainforest? It's a trick question. It's what this means is the GeoIP database didn't have sufficient detail to tell you exactly which city it was. So it just gives you a latitude and longitude that's in the geographic center of the country. Okay, so I've given you 5 things to think about. To go back, if you're a security person, be thinking about this as you're trying to defend the enterprise, as you're trying to get more ingrained in the development lifecycle and working more closely with those teams. If you're not a security team and you're one of these other people, well, think about it from the other angle. Think about how you could maybe gently suggest to some of your peers on the security teams that you might work together in slightly different ways. Test early and often. Don't scan and scold. Push back as far as you can earlier in the dev cycle so that flaws are easier and cheaper to fix. Focus on remediation, measurement, and don't expect to be perfect. Expect to be getting better over time and educate as you go. Figure out what you have. Figure out what's on your perimeter. Get rid of the stuff that you don't need anymore, just decommission it. And start figuring out from an attacker's point of view, where are my weakest links? And once you figure out what those are, figure out what they're connected to. Educate bidirectionally. Security team needs to teach the QA teams, the developers, the management, get executive buy-in on the security process, but also take the time to learn how they're working. Whether it's Scrum, or whether it's Waterfall, or whether it's something that's sort of in the middle. Forrester likes to call that Agile Scrum Fall. incorporating elements of both methodologies. Figure out how they work, what drives them, what motivates them, what their constraints are, and don't assume the worst. Again, don't remember that nobody is trying to develop bad software. So don't assign motivations that aren't actually there. Be very specific in the goals that you're setting for the team and the things that you're asking them to do. Make sure they're measurable, or no one's going to do them. And then remember, the ecosystem is more complicated than just the stuff you're developing within your four walls. And start to think about not just the stuff that you're buying and deploying, but the complexity of each application that you're developing and how many dependencies that thing has on software that's written by people that you don't know and where the risk is unknown, where you've never done any sort of assessment of the code that you're pulling in and just treating as your own. You do these things, it's not easy, but over time you can get there, and you have to be constantly thinking about evaluating, like I said, what's working, what's not working, and what can get better. With any luck, the security team will catch up, everyone will be happy, and you'll get rid of that sort of adversarial relationship that is so common in terms of how security teams are perceived. So those are my learnings. I'm happy to take any questions. I don't have any more material. Yeah.
I work in the ISO office, and we realized that we need to develop a secure coding process and code review. And the first thing I realized we need automated tools to do that. My question would be, well, first of all, I'd have to justify, I'd have to show, hey, we've got some issues here. So would I download some free tools and do some scans? Would I do a 30-day trial and say, hey, here's the current issues that we have to justify, all that?
Yeah. How do you basically raise awareness? Is kind of what you're asking, and justify why would you need to do this at all?
Right.
And if it's not already kind of on the forefront by looking at all the data breaches that are happening, and how people are affected and the costs of those breaches. I mean, one way to do it is to take something that's in development, that maybe something high profile, right, within the company, and do a trial, do a proof of concept with some technology, and figure out what could be improved upon. What you don't want to do is walk in and ambush people with that information. Because then developers will get defensive, and it's just not the best way to approach it. But what you can say is, look, what we're trying to do is protect the information of our customers, or whatever the app is doing. I don't know, health information, credit card information, and to achieve those goals, it's important to understand what the attacker's mindset is, what the holes are in the software, and you can't expect a developer to be a security expert. That's unreasonable. So use tools at your disposal to help figure those things out, to work with them on the process. That's kind of how I would position it if I were starting from scratch. Anyone else? Everyone's tired. All right, thank you very much.